So, remainder theorem says if you take some polynomial, p of x, and divide it by a linear factor, x minus a, you'll get a polynomial plus some remainder over x minus a. And if that's, when you do that division, it turns out that p of a is the remainder. That's what the remainder theorem says. Now, this division is pretty similar to, we're doing using polynomials, but it's pretty similar as if we were to do it numerically. For example, if we have 432 divided by 5, I do my long division. 5 goes into 43, 8. I carry that out. I get 86. This thing that I got down here, that's my remainder of 2. We write that 432 over 5 is 86 plus remainder 2 over 5. So to see the remainder theorem in action, let's suppose we have some polynomial here divided by something in the form of x minus a. In this case, my a is going to be a negative 1. If I do that division, I'm going to get some polynomial q of x plus a remainder over x plus 1. Now we can do this division using the synthetic division. When I set it up, do my synthetic division. Since I started with a cubic here, I'm going to end up with a quadratic with q of x. Think about an x cubed over x is going to give me a quadratic. So this q of x is going to be 3x squared minus 3x plus 7 plus a remainder of negative 14 over x plus 1. Now, let's see why the remainder theorem works, why indeed that p of a is my remainder. Suppose I've done my long division, some polynomial divided by linear factor x minus a, I get some other polynomial q of x plus a remainder over x minus a. If I multiply both sides by x minus a, I'm going to get p of x equals q of x times x minus a plus that remainder. Now evaluate this expression, simply look at p of a. Everywhere there's an x, put in an a. So I get p of a equals q of, it would actually be q of a, times, if I plug in an a minus a is 0. 0 times anything is 0, so I get my p of a equals r. From the remainder theorem, which is kind of cool, the other theorem that develops from that is called the factor theorem. And it states that when a polynomial p of x, if you have that polynomial, x minus a will be a factor of p of x if and only if p of a equals 0. So the if and only if part of the factor theorem implies there are two if-thens that are true. So if x minus a is a factor, then p of a is 0. And if p of a is 0, then x minus a is a factor. And both of these should seem pretty apparent if you consider the remainder theorem. If x minus a is a factor, that means my remainder must be 0. From the remainder theorem, we know that p of a is the remainder, so p of a must be 0. And conversely, if p of a equals 0 from the remainder theorem, we know that x minus a is a factor. Voila. So let's consider one example here. Suppose you've got some polynomial, 3x cubed plus 4x minus 7, and I want to look at x minus 1 to consider if it's a factor or not. I would consider p of 1 using the factor theorem and see if it equals 0. So p of 1 is going to be 0, so indeed x minus 1 is a factor. That's applying the factor theorem to determine if a linear factor x minus 1 is a factor of this polynomial, if it divides it evenly. Now again, just a little practice on synthetic division. Let's check and just go ahead and divide x minus 1 into 3x cubed plus 4x minus 7 using synthetic division, and you get 0 as your remainder. Thinking about the setup of 3x cubed plus 4x minus 7 over x minus 1, here, what I've done is found that to be a quotient, so polynomial divided by x minus a, I get a quotient plus some remainder over x minus 1.